Have you ever picked up a product and just wondered, what's the real story here? What's its actual environmental footprint from the cradle to the grave? Well, today we're going to pull back the curtain and look inside the engine that makes all of that possible, the Life Cycle Impact Assessment.
But let's start with a bit of a puzzle. Let's say you're calculating a product's impact on climate change, and that process releases CO2, methane, and nitrous oxide. Now, you can't just add 1 kilogram of each, right? I mean, that would be like adding a grape, a pumpkin, and a banana and just calling it 3 things. They're totally different. They have wildly different effects on the environment, so how on earth do we add them up? Well, that's the exact problem this whole process is built to solve.
Okay, so where do we even begin? The whole journey starts with something called the Life Cycle Inventory, or LCI for short. Just think of it as step 1 in our environmental accounting. It's where we create this huge, incredibly detailed list of every single thing that goes into a product and every single thing that comes out.
And this image here, it really shows you what we're talking about. Over on the left, you've got all your inputs. We're talking oil, water, minerals, you name it. And on the right, all the outputs, emissions into the air, waste into the water, and so on. It is, and I'm not exaggerating, basically the longest, most complicated shopping list you can possibly imagine. And just like a giant pile of raw ingredients, it's not really useful until we start to cook with it.
So, what's the very first thing you do when you have a massive pile of ingredients for a dozen different recipes? You sort them, right? And that's exactly what we do here. This is the first mandatory step according to the international standards, and it's called classification. We're going to take every single item from that giant list and start sorting them into piles based on the kind of environmental dish they can cook up.
At its heart, this is all about getting organized. You take every emission, every resource used, and you assign it to the environmental problem it relates to. And this isn't just a nice idea. The ISO 1404 standard, which is kind of the rule book for all this, says you have to do this. It's the foundation for everything else we're about to do.
So what are these dishes we're sorting everything for? Well, in the biz, they're called impact categories. And here are some of the heavy hitters on the environmental menu. You've got climate change, of course, that's the big one everyone's heard of, but there's also acidification, acid rain, eutrophication, which is what causes those nasty algae blooms in lakes, and a whole bunch of others, like ozone depletion and smog.
Now here's a really key detail. A single ingredient can actually be part of multiple recipes. Let's take methane. When we're classifying it, it obviously gets put in the climate change pile, but it also gets put in the smog formation pile because, it contributes to both of those problems. This whole multi-assignment thing is absolutely crucial to getting the full picture.
All right, our ingredients are all sorted into the right piles. Now it's time for the master recipe. This is our second mandatory step, and it's called characterization. And trust me, this is where the real magic happens.
Characterization is the step that finally solves that puzzle we started with. It's the moment we take all those different chemicals in one pile, like our CO2, methane, and nitrous oxide in the climate change pile, and we convert them into one single comparable number. It's what lets us finally add them all together. And how does it do that? Well, with a little something I like to call the magic ingredient, the characterization factor. It's basically a conversion rate. It's this number, backed by a ton of science, that tells us how potent one substance is compared to another for a very specific environmental problem. It's what makes an apple-to-apple comparison possible.
Think of this as our recipe card. See? On the left, we've got our different substances, and in the middle, each one has its own unique characterization factor that links it to an impact. See methane there? Its factor for global warming is 23. That means that kilogram for kilogram, scientists have calculated it's 23 times more potent than CO2 at trapping heat over a certain period. That number is the key.
And the math itself? It's actually beautifully simple. You just take the amount of your substance. Let's say we have 1 kilogram of methane from our inventory. You look up its characterization factor for climate change, which we just saw is 23. You multiply them together, 1 times 23, and boom, you get your impact score, 23 kilograms of CO2 equivalents. You do that for every single substance in every category, add them up, and you're done. Simple, right? But so powerful. Okay, so we've cooked our dishes, we've got our final impact scores. Now, there are a couple of optional steps we can take to really add some context. You can think of this as the plating and presentation phase. It's all about making the final results easier for people to actually understand and use.
These 2 steps are called normalization and weighting. So normalization basically answers the question, okay, but how big is this impact really? It helps you understand the scale by comparing your product's score to some huge reference total, like the entire yearly impact of an average person. It's like comparing your single dish to the entire buffet. Weighting, on the other hand, that's a different beast. It tries to answer which environmental problem is worse. And to do that, you have to apply value judgments, saying that maybe climate change is more important than smog. It's like deciding the main course matters more than the dessert. It can be super useful, but you have to be really careful because it's based on values, not just science.
So after all that, the sorting, the calculating, maybe some plating and presentation, what do we actually have at the end of the day?
What you get is the LCIA profile. And really, it's an environmental report card. It's a clean, simple menu that lists out the potential impact scores for each category. This much for climate change, that much for acidification, and so on. It takes that gigantic, messy, overwhelming shopping list we started with and turns it into an organized summary that a designer or a policymaker can actually look at to make a real-world decision.
But, and this is probably the most important thing to remember, this report card doesn't just hand us the right answer. It's almost never the case that one product is better in every single category. No, what this does is shine a bright light on the trade-offs. Maybe this new design has a smaller carbon footprint, but it uses way more water. So this incredible calculation, it doesn't give us easy answers. It forces us to ask the right and, often very difficult questions. Which leads us with the biggest question of all. What trade-offs are we willing to make?